I'm sharing my screen.
They are going to share the screen. Because writing. Yes. Okay.
I hope my screen is visible to everyone. So let's start. This presentation is on behalf of Integrated Microsystems, and I'll be walking you through how image processing, segmentation, and modeling workflows play a crucial role in orthopedic planning, implant fitting, and simulation. We'll also look both manual and automated tools offered by Simpleware that makes this possible. So let's begin with understanding what orthopedic imaging and segmentation actually involve. Orthopedics as a discipline relies heavily on imaging techniques for diagnosis, planning, and treatment. In clinical orthopedics, we often deal with complex anatomical structures such as bones, joints, ligaments, and cartilage. Segmentations is the process of isolating specific anatomical structures from medical images, enabling doctors and engineers to create 3D models that are highly accurate and patient specific. For example, when preparing for a total hip replacement, it is crucial to segment the pelvis and femur from the CT scan to design a well-fitting implant. This can also be extended to applications such as pre-operative planning and custom implant design. Segmentation also forms the foundation for simulation like finite element analysis and computational fluid dynamics, allowing biomedical engineers to study stress distribution and fluid interactions in orthopedic implants. Synopsys Simpleware simplifies this entire process by offering a user-friendly interface and powerful tools that automate and assist segmentation, ensuring that the models generated are both reliable and clinically useful. Medical imaging forms the foundation of any modeling or simulation task in orthopedics. Among the most common imaging modalities are CT scan, micro CT scans, and MRI scans. CT, or we can say computed tomography, is especially useful for visualizing bone due to its highly contrast and spatial resolution. MRI, that is magnetic resonance imaging, on the other hand, excels in visualizing soft tissues like ligaments, cartilage, and tendons. Each imaging modality produces data in the form of voxels, which are essentially 3D pixels. The intensity of each voxel, particularly in CT, is measured in housing units, which corresponds to tissue density. For instance, cortical bone, which is below the femur, has a high HU value, whereas soft tissues and air have lower values. However, medical images often suffer from artifacts, noise, and incomplete slices, especially in regions where there is patient movements of mechanical implants. This makes it essential to pre-process image before segmentation. Simpleware provides tools that address these challenges by offering filters, artifact removal tools, and contrast enhancement. This ensures that the image data fed into the segmentation and modeling pipeline is of the highest possible quality, makes subsequent steps more reliable and accurate. So understanding these basic rules is crucial to maximizing Simpleware potential. So let's begin with a quick recap of Synopsys Simpleware software. Let's Synopsys Simpleware software is an integrated software suite designed to process and visualize 3D image data acquired from modalities like CT scan, macro CT scan, and MRI scan. What makes it especially powerful is its capability to segment and model complex anatomical structures with a high level of precision. It is used not only in biomedical applications but also in material science. The strength of the software lies in its comprehensive toolbox, which includes tools for resampling, cropping, segmentation, surface and volume meshing, and even automated segmentation modules powered by machine learning. Furthermore, is compatible with simulation platforms like ANSYS, Console, Abacus, and design platforms like SolidWorks and CAD. It makes it all-in-one solution. Whether you are planning for a surgical implant or preparing a mesh for finite element analysis, Simpleware ensures that the transition from imaging data to engineering or clinical insight is as smooth as accurate as possible. So now coming to the tools, Synopsys Simpleware is packed with a variety of tools designed to handle each step of the modeling workflow, from initial image processing to final model export. The core set of tools includes resample, crop, transform, segmentation toolkit, surface tools, and volume mesh tools. Each of these plays a specific role. Once segmentation is done, the software provides tools for smoothing, filling gaps, and preparing models for export. Measurement tools allow for in-software validation and 3D preview and 3D printing. Whether you are a radiologist, engineer, or surgeon, Simpleware Toolbox is designed to make your workflow intuitive and efficient. So now coming to the brief of the tools, pre-processing is essential step in workflow, and Simpleware offers robust tools to make this possible. The resample tool is used when the scan resolution is too high for memory or needs to be standardized. By adjusting voxel solutions, we ensure that the image retains sufficient anatomical details while improving performance for segmentation and analysis. In scenarios where we receive extremely high resolution macro CT scans, resampling helps us in making the dataset manageable without compromising the fidelity of the critical features. Similarly, the crop tools help in focusing only on the region of interest. For instance, when working on the pelvic data, we may want to isolate the acetabular region to study hip joint pathologies, and cropping reduces the file size and eliminates unnecessary noise artifacts from the rest of the image. Both these tools work on 2D viewer and 3D viewer, providing both flexibility and precision. In addition, the resampling crop tool, the transformation toolkit allows users to rescale, add, or align images, ensuring the data is aligned in consistent anatomical orientation. These tools serve as foundation before initiating segmentation or exporting data for simulation or design. Now coming to segmentation tools. Segmentation is where the imaging data begins to take shape into meaningful anatomical models. One of the foundation tools in Simpleware's segmentation suite is threshold tools. This tools allows user to isolate structures based on voxel intensity, which is especially effective in CT imaging. For example, bone typically has housing fee units, which is above 200 HU. By applying a threshold at this level, uh, we have presets in the software, so we can automatically extract the bony structures from surroundings, soft tissues, and air. The result is binary mask that highlights only the voxels within the selected intensity range. This is a fast and efficient way to segment structures like femur, tibia, and hip bones. Once thresholding is done, manual refinement often becomes necessary, especially in areas where the scan quality is inconsistent or where multiple structures are closely packed. This is where 3D editing tools come in. Using the lasso tool or freeform selection tool, users can manually erase unwanted area or refine boundaries directly in the 3D view. This interactive editing environment makes it easier to clean up segment structures, especially around joints or in case of deformities. These editing tools bridge a gap between automated process and clinical precision, allowing the creation of highly accurate and patient-specific models suitable for further analysis and surgical planning. Further, after the basic segmentation steps like thresholding and 3D editing, refinement is often needed to isolate individual anatomical structures. One of the most efficient tools in this context is the mass split fill. These tools allow users to clean up the segmented mask by removing small disconnected regions or islands that are not of interest. With just one click, Simpleware retains the largest connected region within the active mask and discards smaller irrelevant components. This is particularly useful in scans where noise or calcification generates scattered regions that might otherwise interfere with downstream applications. Another powerful tool is split region tool. When dealing with complex anatomical assemblies such as pelvis, femur, sacrum, these structures are often closely attached in the scan. The split region tools uses watershed algorithm to automatically separate these into distinct parts based on local intensity minima. Each region is then color coded for easily identification. This not only saves time but ensures consistency across different datasets. Finally, the Smart Paint. It is a semi-automated manual painting tool that enhances the user ability to fine-tune boundaries. It uses adaptive region bound, allowing the user to add or subtract mask by brushing over targeted areas. It strikes a balance between manual control and automated assistance, making it an essential tool in complex or irregular segmentation cases. Now coming to the additional tools, once the primary segmentation is completed, the next step is to clean and enhance the segmented structures to make them suitable for modeling or simulation. Simpleware provides several additional tools for this. One of the most frequent is bone filling. The tool addresses issues caused by scan limitations such as small holes or discontinuities in the segmented bone symmetry. It works by interpolating missing data to ensure model is watertight and structurally consistent. The recursive Gaussian filter is another powerful feature that helps smoothing surface and artifacts. In medical imaging, stares that artifacts can appear due to slice resolution. This filter applies Gaussian smoothing in three dimensions, refining the mask or surface to make it more natural and visually accurate without blurring the critical features. Other tools are cavity fill gaps, and Iceland removal. Cavity fills helps close internal voids in the bone structure that are not physiological but are artifacts of poor scan quality. Fill gaps smooth out small disconnected voids, and Iceland removal deletes objects smaller than a specific threshold, ensuring only clinically relevant structure remains. Collectively, these tools prepare the segmented models for robust simulation and 3D printing workflows and ensure no manual post-processing is required in CAD or FEO tools. Now coming to automated segmentation and orthopedics, Simpleware includes specialized automated segmentation modules known as ACE Auto modules. These modules are powered by machine learning and are trained on a broad set of anatomical data, making them highly effective for routine orthopedic tasks. These modules are available for key anatomical regions such as hip, knee, spine, ankle, shoulder, etc. What makes these tools invaluable is their ability to dramatically reduce the time and variability associated with manual segmentation. For example, the ACE AutoHip CT module can automatically segment structures like proximal femurs, pelvis, and sacrum. Similarly, the knee CT and knee MRI modules can segment femur, tibia, patella, and associated cartilage and meniscus. These tools not only isolate the bones but also place anatomical landmarks that are critically for implant planning and biomechanical analysis. With these automated segmentations, users can go from raw DICOM data to simulation ready models within few minutes. This has transformative implications in clinical workflows, medical device research and development, and academic research. In short, the AS Portal suite makes segmentation faster, more consistent, and scalable, especially for users working in large data site or multiple patient cases. The backbone of the automated segmentation modules is Simpleware's integration of machine learning algorithms. Traditional segmentation workflows are often labor-intensive, require skilled personnel and extensive manual intervention. However, the inclusion of AI-based tools allow Simpleware to deliver fast, accurate, and reproducible results. These machine learning algorithms are trained on a wide range of anatomical scans and validate against ground truth models. What differentiates Simpleware approach in its emphasis on generalization and reliability? Algorithms can process CT scans and MRI scans across different scanners, resolutions, and patient anatomies with minimal setup. In many clinical and research and development environments, batch processing of multiple datasets is necessary. Simpleware supports batch workflows, allowing users to run automated segmentations on dozens or even hundreds of scans in a fraction of time it would take manually. Additionally, these AI tools reduce intra and inter-operator variability, which is crucial for studying requiring consistency. By freeing up time from repetitive manual tasks, engineers and doctors can focus on interpretation, analyzing, and decision making by diagnosing the scans. The result is a faster, more efficient workflow that makes high level of anatomical accuracy. Let's now look more closely in anatomy specific features such as AS ortho modules. When working with hip segmentations using CT scans, the module extracts the proximal femor's, pelvis, sacrum, and hip bones. Additionally, it identifies and places anatomical landmarks such as anterior, superior, inferior, posterior, and pubic symphysis and sacral promontory. These landmarks are essential for accurate implant alignment, pelvic tilt assessment, and tire mechanical simulation. For knees specifically, using 3D weighted MRI scans, the software segment structures like the femur, tibia, patella, fibula, and also isolates cartilage regions. This is vital for assessing joint degeneration, designing custom implants, or planning surgeries such as total knee replacement. Furthermore, the module places landmarks at critical points such as femoral and tibial tuberosity. These anatomical features are key for patient-specific measurements and guide the positioning of cutting guides and jigs. This kind of targeted segmentation enables doctors and researchers to analyze, diagnose, measure, and simulate joint behavior with unprecedented precision. It only saves time but improves the clinical utility of models generated. These features make Simpleware ideal in orthopedic departments, medicine clinics, and implant manufacturers. So why automated segmentation is used? To summarize, the AS Auto module in Simpleware is a dedicated auto segmentation solution for orthopedic applications. It brings together the power of machine learning, autonomical intelligence, and workflow automation to address the time-consuming nature of traditional segmentation methods. One of the greatest advantages is that users do not require advanced training in emerging software or manual segmentation techniques. The software guides users through step-by-step process where they can select the anatomical region, import the image, and generate segmentation with single click. These capabilities are especially valuable in settings where time is critical, such as surgical planning, designing prototype, or large-scale clinical studies. For example, a hospital can use AI software to rapidly prepare anatomical models for 10 hip surgeries scheduled in a single week. The consistency and accuracy achieved using US modules ensure that each case is handled with same rigor even with different personnel involved. Moreover, software allows minor manual adjustment if needed, ensuring flexibility without compromising the automated efficiency. By offering repeatable validated workflows, AI software reduces human errors, improves reproducibility, and enhances confidence in downstream modeling, simulation, or fabrication processes. So now coming on SolidWorks. One of the key benefits of using Synopsys Simpleware in orthopedics is its seamless integration with CAD softwares, particularly SolidWorks. This integration is enabled through dedicated module called Simpleware Design Link, which allows user to transfer data back and forth between Simpleware and SolidWorks without needing to export and import files manually. This kind of interoperability streamlines workflows dramatically, especially in the field of implant design where iterative processes are common. Let's say a biomedical engineer is working on designing a custom acetabular cup for a hip replacement. The 3D anatomical model is generated in SimpleWare from a CT scan. Using the design link, the model can be directly brought into SolidWorks where the implant can be designed. Once the design is complete, the implant can be sent back to Simpleware for evaluation in an anatomical context, verifying fit, alignment, and position. This live bidirectional data exchange minimizes data loss, improves accuracy, and reduces turnaround time. Furthermore, design link supports update with a single click. If changes are made to the anatomical model in implant, both environments can be synchronized immediately. The device connectivity empowers engineers and doctors to carry out patient-specific implant design, surgical planning, and iterative testing much faster than traditional segmented workflows. Now coming on tools of implant. After importing a surface model such as implant into Simpleware, the next critical step is accurate placement within the anatomical data. Simpleware provides a comprehensive suite of surface tools designed specially for this purpose. These tools ensure that the imported implants fits precisely within the 3D model of the anatomy, aiding in implant fitting simulations and pre-operative planning. The first tool is to be used is zero position, which automatically centers the implant geometry based on all three axes. This ensures a neutral starting point from which further alignment can be done. Next, register datasets allow positioning the implant relative to anatomical features of the model. For example, when positioning acetabular cup into segmented pelvis, these tools help align the implant to the desired surgical axis. Once roughly positioned, the position and orientation tools offers fine-tuning capabilities. Users can manually rotate, translate, or snap the implant into exact alignment using anatomical landmarks or grid systems. These adjustments can be visualized in both 2D and 3D views, ensuring a precise and intuitive workflow. This process is particularly useful when validating whether a particular implant design will accommodate individual anatomical variability or pathologies like deformities. Altogether, these tools play a vital role in implant position accuracy, design validation, and surgical rehearsals. Synopsys Simpleware is designed to support a variety of image import formats, making it compatible with virtually all common medical and industrial imaging systems. This ensures that no matter where the imaging data comes from, it can be seamlessly integrated into the modeling and simulation pipeline. In the medical domain, Simpleware supports DICOM, which is known as Digital Imaging and Communication in Medicine, which is standard format for radiological imaging such as CT, micro-CT, and MRI. DICOM For industrial images are also supported. Users can also import 2D image stacks including BMP, JPG, TIFF, PNG, GIF, which are often used in research or non-clinical imaging applications. This level of flexibility allows Simpleware to be used not just in orthopedics but in cardiology, neurology, oncology, and even material science. Whether the goal is creating anatomical models, visualizing implants, or preparing data for simulation, Simpleware's robust input capabilities serves as the first critical step in the 3D modeling journey. Once the segmentation and modeling process are complete, the next step is to explore the result visualization, design, simulation, or fabrication. Synopsys Simpleware supports an extensive range of export formats, various downstream applications. These export include surface models, volume meshes, and even high-quality images. So Simpleware FE is a centralized module that allows users to generate finite elements and computational fluid dynamics directly from segmented image data. What makes Simpleware FE exceptionally is its ability to create simulation-ready meshes that do not require additional cleanup or remeshing in external software. This saves both time and effort for researchers and engineers working in simulation-heavy workflows. Using volume and surface meshing tools, users can create high-quality hexahedral and tetrahedral meshes with smooth transitions and well-defined boundaries. These meshes can be designed using specific material properties directly from the intensities value of original scans or from user-defined presets. This is particularly useful in orthopedics where bone density play a crucial role in simulation accuracy. Simpleware FE also provides options to define no threats, contact regions, boundary conditions, and support for anisotropic material properties. Once the model is matched and configured, it can be exported to all major solvers, including Abacus.inp, Ansys.cdd, Console.nes, LSDyna.key, and others. This level of automation and integration ensures that simulation projects can begin with high accuracy, anatomically faithful models, reducing assumptions and improving the fidelity of the results. Now coming to the exports of FE machine. In the Simpleware supports an impressive variety of file formats to ensure interoperability with the most commonly used servers in both academia and industry. Whether you're simulating stress distribution in FANR under load or testing fluid flow with porous implants, Simpleware ensures compatibility with your preferred tools. For structural mechanics simulation, the export includes Backus.imp, Ansys.cdc, LS-Key, Nastran.ns, and console. Mesh types supported includes tetrahedral, hexahedral, shell, and hybrid combination, offering flexibility for simple and complex geometries alike. Additionally, contact surfaces, boundary layers, node sets, and material properties are included in the export package, saving significant time in setup. For CFD applications, Simpleware supports export to Fluent, .msh, OpenFOAM, Console, and VTK, with appropriate definitions for boundary conditions and flow volumes. This makes the software ideal for cardiovascular applications that involve airflow and nasal cavity, blood flow through slanted vessels, or fluid dynamics in joint lubrication, which we will be discussing in upcoming sessions. Also notable is the ability to store FE meshes directly in the Simpleware project file, enabling iterative changes to reuse across projects. The NURBS modules in Simpleware represents a crucial bridge between image-based modeling and traditional CAD workflows. NURBS or we can say non-uniform relational. These plans are mathematical representations used widely in CAD software to describe complex geometry smoothly and accurately. While mesh-based models derived from medical imaging are incredibly precise, many CAD tools require smooth surface definitions that can be manipulated parametrically. This is where the nodes module proves essential. Once a 3D anatomical region is segmented in Simpleware, users can apply the node-splitting algorithms. The software intelligently fits spline patches over the voxel-derived geometry. This switching process preserves key anatomical features while converting the model into a CAD-compatible IGES file. This is especially useful for applications such as prosthetic design, implant design, orthopedic implant planning, preoperative planning, or integration with other mechanical systems. Engineers can import these IGES files directly into platforms like SolidWorks, Cassia, or Siemens NX to modify, analyze, or manufacture the models further. Another advantage of using knobs is the ability to reduce file size significantly while maintaining surface fidelity. This helps in speeding up rendering, simulation setup, and fabrication. For anyone working in CAD heavy environment, this feature makes Simpleware the perfect partner software for closing the loop between anatomy and design. Now coming to computer-aided design, the CAD module in Simpleware allows user to import, manipulate, and position idealized surface objects such as implants or prosthetics within anatomical image data. This is particularly valuable in orthopedics where anatomical accuracy must be combined with engineered designs for effective surgical planning or simulation. Once a CAD model such as acetabular cut or femoral span is inputted into the Simpleware environment, users can position it interactively with the 3D image volume. This alignment process is aided by tools for translation, rotation, and snapping to specific landmarks. Simpleware also allows for Boolean operations, meaning users can perform subtraction or union operations between CAD object and the segmented anatomy. This is extremely useful for planning, designing, cutting guides. Additionally, the CAD module includes an internal structures wizard which allows for the embedding of porous lattice structures into the design. These lattices are especially relevant in the 3D printing of orthopedic implants, where porosity can promote bone growth and long-term fixation. By combining medical imaging and parametric design, the CAD module transforms Simpleware from a passive modeling into a powerful surgical design and validation platform. It also empowers engineers and doctors to perform design adjustments directly on patient-specific anatomical data. Thank you everyone. That is all from this session. We are the seeing demonstration of the hello. Now we will be seeing some auto segmentation part in Simpleware software.
इसका टोटल जनरेट कर लिया उसके बाद दो नंबर और वो डायरेक्ट टोटल हो गया तो आगे सर्च करके कहाँ गया डू नॉट ट्रैवल डिटेल्स ये कहेगा है ना पेपर दिया कि नहीं कितने पे के हैं तो बैच कर रहा है
Hello, please, Wasim and can you please mute your mic? Hello. So,
एक्चुअली सब चले गए हाँ नीचे डायरेक्टर रूम में मिलेंगे भाई
do anyone have any questions
अभी तो हमने साइन करा के रखा
we
है
can ask regarding this session? And then we can head to automatic segmentation in Simpleware software.
ये होगा
So I hope there is no queries. So we are moving towards auto segmentation part in Simpleware software. So this is the basic interface in the Simpleware software. Here is image processing, auto segmentation parts. So now we will be importing one file.
Hey, Hi, Mr. Wasim. Can you please turn off your mic? There's some echo from your end.
From here we are taking an example of ankle. So we have three 2D viewers and one 3D viewers. So now we are going to auto segment this entry.
Hi, Mr.
So we
Wasim.
don't have to,
I'm following Pratik for a second. Mr. Wasim, can you please turn off your mic? There's some echo from your end. Yes, Pratik, continue.
so as we can see, is a 3D image derived from ankle scans. So now we just have to click on this ankle city and region of interest automatic anti-vision. This automatically selects active background diagram. Now we will select create landmarks also and keep all bone fragments. We will just click on apply.
11:30 तो आएगा वही तो
So it will take sometimes few seconds or few minutes.
11:15 तो 11:12 होगा कहाँ पहुँचे भैया ठीक ठीक
एक भैया देखिए और राइट में आएगा 11 20 11 20 को टाइम चाहिए 11 20 बजे तक का मैं तो कई एडी पुलिया है ना भाई हाँ भाई इंजीनियरिंग कॉलेज पास करना है So it identified all the tissues and bones like fibula, talus, tibia. So we click on the OK and preview the image. It basically segmented the bone part of ankle and automatically colored different parts and region of interest like tibia, talus, fibula, muscles. From here we can work on our specific part. We can also we can also manually segment something like uh, if the bone filling is not done yet, if the surface is if the surface is deformities, we can correct it from here. So with this, we can like work on this specific part. Like we have to work on this particular part. So we select all the other parts. So we'll work on that. And from here, we can get the measurements. It automatically selected the landmarks for us. For example, if we want to see the distance from here to here is 16.55 mm, and all the functions we can do with it. Similarly, if we take the example of knee city,
Diva, Diva,
so as you see, the auto segmentation part is really helpful and really fast. So here also we have three 2D viewers and one 3D viewer. This is our raw data which 3D viewer has identified. So now we'll auto segment this. So we just have to click uh, new city part. It also automatically select the mask and automatic new region, and we have to click on keep all one fragments. And now we click on apply. It segments very accurately that we do not have to uh, further enhance it with manual segmentation tools. But if you want, you can also use manual segmentation tools to enhance it. So see how fast it does. So it identified all the mass and bones and tissues. So we'll click on OK and we'll click on fast preview. See how it generates uh, all the segmented parts. So if we want to like manually uh, enhance it. Like if we want to like delete this part, we'll use 3D editing, and then in simple 3D editing, we'll click on delete option, and then we'll click on lasso tool. So what it does, like uh, so it is a free form tool which we can use to delete a specific segment that is not in our region of interest. So see how fast it operated. Similarly for this part,
Mm,
and
देख
like if you want to use
वॉइस बढ़ा दे भाई.
if you want to use the bone filling section, it already does the bone filling. But if you still want to use the bone filling section, so it is only for one click. So basically, it does for different parts. So first we are using it for tibia. So now clicking on the apply section, and now fast preview. So it basically does some work here, but it already like auto segmented did a lot of work in it. So we can't see a major uh, update in it. The first thing we can do for this, uh, so now coming on the mask flip fill options. Like if we want to keep a certain island and delete a different island from it, so that is how Aspect well, Flatfill comes in. We'll use first simple 3D editing tool or delete and lasso tool. First, we'll basically hide the details, and if you work on it, if we let's say if we delete this part, let's say we have created two segments out of it. So if we want to delete this part out of the main region of interest, we click on mask factorial and we just have to uh, click on so so now we have selected the active mask as trivia, so we just have to click on the bigger island to remove the smaller island or the region that we are not of interest. So we click on the region of interest, so it will basically removes the other smaller islands from our project. So that is how it works. So now let's take an example of uh, um, let's take an example of knee MRI. So I think this knee MRI, it has option of knee MRI. So as we are working on 3D viewers, so we'll expand it. And now we just have to click on auto segmentation, knee MRI, and it automatically selected the mask. We just have to click on convert to smooth geometry and apply. So it is taking some time. We will wait for it. It also depends on the GPU of any system that the software is working on. So it identified all the issues. So we will click on generate fast preview, see how it generates the MRI version of me. Previously, we were seeing the CT scan version of me, so it is an MRI version of me segmentation. So, do anyone have any doubts in this auto segmentation part? We'll be seeing hip CT part in the next session, and we'll be giving it a brief time. So, I think it is like perfectly segmented. We don't have to use any manual tools in it. So, if anyone have any doubt in the 3D segmentation, after segmentation part, so you can ask. We'll be covering the pelvis part in the next session. We will be demonstrating it.
Right. So, does anyone have any queries? They can kindly let us know. Till now, in the second session, we shall be focusing on the auto segmentation for other parts, as well as focused by the external models, how we can integrate different types of our segmentation algorithm in the software. And we shall be also going through different tools like how to optimize the structure for 3D printing and the finite element analysis and CFD modeling tool. So, if there are any queries, the session is open for question and answers. Kindly let us know. Also, if anyone is facing any issues while registering for the trial version, they can also contact me through my WhatsApp. I have already shared the number so that I can facilitate the process quite easy over there. So no queries I think in this session. But still, if there are any queries, you can let us know. We'll definitely try to cover it in the afternoon session. Also regarding the trial version, I'm just working on it how to facilitate the process easily. Yeah. So that's all for this morning session. Thanks everyone for joining. I think Dr. Pandita is here. Ma'am, do you have any queries? Yeah, thank you, Dr. Jamir, for kind regards. So no queries. Then I'll see you all in afternoon session. So thank you everyone for joining.